Dr. Eric Davis from Earth Tech, right? And that's
Institute for Advanced Studies at Austin.
Oh, okay.
Which is, you could say both or one.
Well, can you tell me a little bit about what you're presenting about this year?
Well, actually, I'm presenting 3 papers, and 2 papers as a first author and 1 paper as a co-author. The first of my 2 papers is first author. One of them is I'm reviewing experimental concepts for studying ways to extract energy from the quantum vacuum. And it's basically a summary of some experimental concepts that we've been exploring and we're going to be doing in the laboratory to see if we can extract energy from the zero-point fluctuations. We're also putting a little background history on the zero-point fluctuations, what it is physically, its numerical magnitudes and consequences if we can extract such energy for applications in commercial spaceflight, commercial power systems, and so forth. The other paper I'm authoring is on a review of laboratory concepts for extracting negative energy, or generating negative energy in the laboratory that would be used for generating FTL space-times. And like traversable wormholes or Alcubierre warp drive or Krasnikov tube warp drives or whatever, the idea is to look at the definition of negative energy so that people who are not specialists in general relativity can understand what it really means. The term is misapplied and misused so much that everybody gets confused and don't know what they're talking about usually. So I'm going to clear that up by describing what negative energy is, give its physical definition, and then examine the background of the kinds of effects in quantum theory where negative energy is known to be generated. And then I'm going to look at some selected concepts that have been developed that could hopefully produce negative energy in the laboratory by the way of advanced quantum optics techniques. The other paper is a paper joint with Harold White from NASA Johnson Space Center. He's doing this as a private citizen and not as a NASA employee as part of his graduate thesis work for his PhD in general relativity. It's on examining Alcubierre's warp drive in higher dimensional space-times using D-brane theory. And we show that in D-brane theory, you can actually eliminate the negative energy requirement and replace it with the positive energy and a negative pressure.
Well, this is a real breakthrough paper, right? Because this is at least from what I've seen, this is the first time we've ever seen an applied physics approach to string of brane theory.
Right.
So that's a real hallmark achievement.
Right, and the idea is we believe that the Alcubierre metric or any kind of warp metric really represents a velocity boost that goes off the brane that we live on into the higher dimensional space, and the equation of state of matter or energy that you need to affect that physical thing would give you requirement for positive energy and negative pressure, so not any negative exotic matter at all is required. The equation of state looks like the dark energy equation of state in the universe. And so Harold had proposed a first order or rough sketch lab experiment that we could do using lasers in order to try to see if we could test this theory.
Oh, okay.